$3. That's what the man at the tailgate wanted for it. $3 for a hand drill so orange with rust that the crank wouldn't move a quarter turn. He'd priced it like scrap because to him, that's what it was. $280. That's what's sitting dead in the bottom drawer of my shop bench right now. 2 cordless drills, 4 battery packs, and a charger for a platform that nobody has made a pack for since my son was in high school. Every one of them works. Not one of them will turn. So I bought the $3 one. I took it home, I put it in a bucket overnight, and the next morning I put a dial indicator on the chuck and spun it. 0.003 of an inch of runout. 3. That's less wobble than the keyless chuck on the Cordless I paid $189 for in 2019. A tool somebody threw in a milk crate 100 years ago is more accurate than the one I bought new, and it cost me the price of a cup of coffee at a gas station. My name is Verna Ward. I'm 63 years old. I've lived on the same 40 acres of Ozark chert and clay in Carter County, Missouri my whole life, and I have never in that time bought a drill bit I didn't first learn to sharpen. The drill I'm going to show you today isn't the $3 one. The $3 one is in the bucket. The one on my bench is my grandmother's, and it's the reason I knew what I was looking at on that tailgate. Her name was Verna Ward. She was born in 1911 in a house with a dirt floor about 11 miles from where I'm sitting. She hung her own cabinet doors, and when she died in 1994, that drill was in her kitchen drawer, wrapped in a shop rag, oiled. 32 years later, it still turns like it's floating. Stay with me on this one. By the end, you'll know exactly what to buy, what it costs, how long the soak takes, and the one mistake that will ruin a 100-year-old tool in about 40 minutes. That last part is the part nobody tells you, and it's the part I got wrong the first time. Go open the drawer, you know the one. There's a cordless drill in there with a battery that holds a charge for about 90 seconds. There's a second battery next to it that doesn't hold one at all. There's a charger with a cord wrapped around it, and if you plug that charger in right now, the light will come on, because the charger is fine. The charger was always fine. And somewhere in that same drawer or that same garage, there's a bit that won't seat straight. You chuck it up, you pull the trigger, and the bit walks. It draws a little orange circle in the air instead of a point. You lean on it. It skates across the wood and leaves a scar you have to fill. That's runout. Runout is the amount a chuck lets a bit wobble off center, and it's measured in thousandths of an inch with a dial indicator, which is a gauge with a needle that reads how far a surface moves as you spin it. 5 thousandths, and you'll never notice on a fence post. 15 thousandths, and you cannot drill a straight hole for a cabinet hinge, no matter how steady your hands are. Nobody prints that number on a box anymore. Nobody prints it because nobody measures it, and nobody measures it because the tool isn't meant to be around long enough for it to matter. That's the real problem. Not that your drill is dying, that your drill was designed to. Here's what happens when the pack dies. You go looking for a replacement, and you find one, and it costs somewhere between $60 and $110, which is more than half of what the whole kit cost you when it was new, with 2 packs and a charger and a plastic case. So you look at a new kit instead, and the new kit is a different voltage on a different platform, which means your old charger is trash, and the 2 dead packs are trash, and the drill body itself, which has nothing wrong with it at all, is trash. That's not a battery failing, that's a system working exactly the way it was drawn up. And the part that ought to bother you is the arithmetic underneath it. Lithium cells lose capacity by cycle count and by age, whether you use them or not. A pack sitting on a shelf in a hot garage in July is dying on the shelf. So the clock on that tool started the day it was built, not the day you bought it. Now count what that costs across a working life. Say you replace the whole thing every 7 years. That's a conservative number. From 25 to 65, that's 5 or 6 drills. Call it $1,100, low, not counting bits. Verna paid for hers once. I don't know what she paid. I know the man who sold me the second one wanted $3. And I know the going price at an Ozark farm auction for a box of hand tools with a drill in it is somewhere between $2 and $15, depending on how many people showed up. One of those 2 numbers goes up every year. The other one hasn't moved since I was a boy. Verna did 3 things. That's the whole method. I want you to hear how little it is. She used the tool. She wiped the tool. She oiled the tool and put it somewhere dry. That's it. There was no restoration. There was no project. There was a rag hanging on a nail by the back door and a can of oil on the sill, and when she was done drilling a hole, she wiped the chuck and the gear and set it in the drawer. Now here's why that worked. Because it isn't sentiment, it's chemistry. Rust needs three things, and only three: iron, oxygen, and water. Take away any one of the three and the reaction stops cold. It doesn't slow down, it stops. Oil doesn't protect steel because oil is magic. Oil protects steel because oil is a physical barrier that keeps water molecules from touching iron atoms. A film 4/10,000ths of an inch thick is enough. That's the whole secret. A rag and 11 cents of oil, 30 seconds, once. Which means every rusted tool you've ever seen at a flea market is a tool that somebody stopped doing 30 seconds of work on. Not a tool that failed. A tool that got put down wet, one time, in a shed with a dirt floor, and then left for 40 years. And that matters more than it sounds, because it tells you what you're actually buying for $3. You are not buying a broken machine. You are buying a perfectly good machine with a chemical crust on it. Those are different problems, and only one of them is hard. Steel doesn't rust away evenly like a bar of soap. It rusts in pits, and the pit runs deeper than the surface tells you. That's why sandpaper is the wrong tool. Sandpaper takes off good steel across the whole surface to reach down into a pit that's 1/8 of an inch across. You end up removing 100 times more metal than the rust ever ate. There's a better way, and it's older than you'd think. Chelation, that's the word. Chelation is when a molecule wraps around a metal ion and holds it, the way a hand closes around a marble. The word comes from the Greek for claw. A chelating molecule grabs the iron out of the rust, pulls it into the water, and carries it away in solution. And here's the part that gets me every time. The best cheap chelator for iron is citric acid, the same acid that makes a lemon sour. The exact same molecule, in the form of citrate, is what your own bloodstream and your own cells use to move iron around inside you. The chemistry that makes a lemon bite your tongue is the chemistry that keeps iron circulating in your body. And it's the chemistry that will lift 100 years of rust off your grandmother's drill in a bucket overnight. Now, why doesn't it eat the good steel too? Because it barely can. Citric acid at the strength we're using goes after iron oxide, the rust, fast, and after solid iron, very slowly. It is not hydrochloric acid. It will not hollow out your tool while you sleep. It will, if you leave it a full day and a night, start to etch and dull the bright surfaces, so we're not going to leave it that long. And I'll tell you exactly how to check. The alternative is electrolysis, which is the same job done with electricity instead of acid, and I'll cover the setup, because for a badly seized drill, it's the better answer. In electrolysis, you put the tool in a bucket of water with washing soda dissolved in it. You hook the tool to the negative side of a battery charger, and you hook a piece of scrap steel to the positive side. Current flows. The scrap steel corrodes and gives itself up. The rust on your tool loosens and falls off. That scrap bar has a name. It's called a sacrificial anode, and it's the part that rusts on purpose, so the part you care about doesn't. You already own one. There's a magnesium or aluminum rod hanging inside your water heater, doing that exact job right now. And if you've never replaced it, that's why the tank went out at 11 years instead of 25. Same reaction, same principle. A boat hull has them bolted to the transom. Your water heater has one screwed into the top, and you're about to put one in a 5-gallon bucket in your driveway. Short list. Nothing here is specialty. Citric acid, anhydrous, food grade. It's sold for canning and home brewing. 2 pounds runs $8 to $12 at a grocery store, a brewing supply, or a farm store. 2 pounds does 5 or 6 buckets. That's the whole active ingredient. Washing soda, which is sodium carbonate, not baking soda. The yellow box in the laundry aisle, about $5. One box lasts years, only needed if you go the electrolysis route. Baking soda, sodium bicarbonate, $1. This is your neutralizer after the acid soak, and it is not optional. A 5-gallon plastic bucket, free behind most any bakery or deli, or $4 new, plastic only, never metal. A brass brush and a gray or maroon abrasive pad, $6 for both. Brass is softer than steel, so it lifts the loosened oxide without cutting into the tool. Light machine oil, 3-in-1 or any non-gumming machine oil, $4. If you want the traditional answer, camellia oil, which is the pressed oil Japanese toolmakers have used on plane blades for generations because it doesn't gum or go rancid. It runs about $12 for a small bottle, and it will outlast the drill. White lithium grease, a small tube, $5, for the gear teeth only. Boiled linseed oil for the wood handles, $8 a pint, and I will come back to that one because it carries a real hazard. Total, if you own none of it, about $40, and you'll have enough left over to do a dozen more tools. Compare that against a gallon of the commercial rust remover on the end cap at the hardware store, which is $25 to $30 and is, in most cases, a chelating agent in water. You are buying the same idea with a label on it. If you've already tried one of these soaks and it went sideways on you, or if it worked and you've got a tool you're proud of, put it in the comments. I read them. I especially want to hear from anybody who's pulled a plane or a brace out of a barn, because those two have a wrinkle I'm still arguing with myself about. Now let's be plain about it, and let's be fair about it, because I don't want to sell you a villain that isn't there. Nobody is hiding citric acid. It's in your pantry. It's on a shelf in every grocery store in this country, under a food additive code E330, because it's in your soda and your canned tomatoes. What's happened is quieter than a conspiracy and worse than one. The whole business model of a hand tool moved. It used to be that a company sold you one object and made its money on that object being good enough that your neighbor bought one too. The Millers Falls Company of Millers Falls, Massachusetts, was building drills on that model from the 1860s. Goodell-Pratt was doing the same thing 30 miles away in Greenfield, and Millers Falls absorbed them in 1931. Those companies competed on how the thing ran, because the thing was going to be around for 50 years and everybody knew it. Today the object is the cheap part. The money is in the platform, the battery, the charger, the fitting that only takes their pack. That's not a tool company anymore. That's a subscription with a chuck on the end of it. And here's the consequence that ought to make you cold. When the money moved to the platform, the specifications stopped being published. Nobody advertises chuck runout. Nobody advertises gear material. Nobody advertises bearing type. Those were selling points in 1925 because they were the only selling points. Now the selling point is torque, which is a number that means almost nothing for a hole in a cabinet door, and voltage, which means even less. They stopped measuring the number that tells you whether the tool is any good, and they started measuring the number that sounds impressive in a commercial. The $3 drill in my bucket has that number. It has it because somebody in Massachusetts 100 years ago cut those bevel gears to a standard and expected to be judged on it. You can still measure it. It's still there. It's just under a 1/4 inch of orange. Here's the whole thing, in order. Don't skip and don't reorder. Take it apart first. Every hand drill of this pattern comes apart with a screwdriver and patience. Handle off, side knob off, crank and gear off, chuck jaws out. Lay it on a rag in the order it came off and take a picture with your phone before each step. Every wood part comes off and stays out of the bucket. Wood in acid is a ruined handle. Look at the frame before it goes in. If there's black or red finish still clinging to the cast frame, that's Japanning. Japanning is a hard black asphalt-based varnish that was baked on in an oven at the factory, and it's the original finish. Acid strips it. Electrolysis strips it. If you want it kept, mask it with tape and wax, and don't submerge the frame at all. Wipe that part by hand with oil and a rag, and leave it be. Mix the bath. A heaping 1/4 cup of citric acid, roughly 2 ounces, per gallon of hot tap water, around 120 degrees. Stir until it's clear. If your parts need 1.5 gallons, mix 1.5 gallons. Don't guess it's strong, thinking strong is faster. It isn't. Submerge. Everything steel goes in and stays under. Anything sticking out of the water will get a hard line etched into it right at the water line. Check at 2 hours. Pull a piece with tongs. Wipe it with the brass brush. Look. Light surface rust is often done at 4 hours. A seized crank with heavy scale might want 8. I have never needed more than 12. And past 12, you're etching good steel for no gain. Bubbles coming off the parts are normal. That's hydrogen. Do it outside or in a ventilated space and keep flame away from it. Neutralize immediately. This is the step people skip, and it's the one that costs them the tool. Out of the acid, straight into a bucket of hot water with a tablespoon of baking soda per quart. Slosh it. 2 minutes. Then a clean hot water rinse, dry with heat, right now. Not a towel, a hairdryer or a heat gun on low, or 10 minutes in an oven at 200 degrees with the wood parts nowhere near it. You have about 10 minutes before flash rust starts. Flash rust is the fine orange bloom that appears on bare steel almost immediately after you strip it, because the metal is now chemically naked and wet, and it will happen while you're standing there looking at it. Oil while it's still warm. Machine oil or camellia oil on a rag, every surface, immediately. Warm steel takes oil deeper. Grease the gear teeth only. A pea of white lithium worked into the teeth of the main wheel and the pinion. The pinion is the small gear that meshes with the big crank wheel, and it's the part that does the multiplying. Grease on the gears, oil on the bearings and the shaft, and nowhere else. Excess grease on the frame is a dust magnet, and in a woodshop, it turns into a paste that grinds. Handle finish. Clean the wood with mineral spirits and a rag, not water. Then boiled linseed oil, wiped on thin, wiped off after 15 minutes, left overnight. And listen to me on this next part. Linseed oil cures by oxidation, which generates heat, and a wadded oily rag left in a pile can and does catch fire on its own. That is not a rumor. Lay every rag out flat and single on concrete outdoors until it's stiff, or drown it in a can of water with a lid. People lose shops to this every year. That polymerizing reaction, incidentally, is the same one that dried the oil paintings hanging in every museum on Earth. A tool handle in a Missouri shop and a canvas from 1620 cure by exactly the same chemistry, and both of them get harder every year they sit. Reassemble and test. Crank it. Listen. It should be quiet and even, with no catch at any point in the rotation. Fast, because these are the ones that cost people the tool. Stainless steel as your anode in electrolysis. Never. Stainless contains chromium, and running current through it in that bath produces hexavalent chromium in your water, which is a confirmed carcinogen and a hazardous waste you now have to deal with. Use plain, mild steel scrap. Rebar. A piece of flat bar. Nothing shiny. A wire wheel on a bench grinder against the gear teeth. It looks efficient, and it rounds the tooth profile. And once the profile is wrong, the mesh binds and there's no fixing it. Brass brush by hand. Always. Baking soda instead of washing soda for electrolysis. Different chemical, weaker conductor, worse result. Leaving it in the acid overnight because you fell asleep. Set a timer. Set 2. Sanding old painted handles dry. Household paint before 1978 in this country could contain lead, and a lot of old tool handles wore household paint. Don't create dust. Wet sand, or leave the finish alone. Painting the frame. I'll say this plain, and you can disagree with me in the comments. A repainted tool is worth less to everybody, including you, than an honest one with worn Japanning. The wear is the record. Storing it in an unheated shed on a concrete floor. Concrete wicks moisture, and the air over it swings through the dew point twice a day. That's how it got rusty the first time. This part takes 30 seconds a year and 1 minute after each use. After use, wipe the chuck and the bright steel with an oiled rag. That's the rag on the nail. That's Verna's whole system, and it beat everything that came after it. Once a year, a drop of machine oil at each bearing point and at the crankshaft, and a check of the gear grease. If the grease has gone dark and gritty with sawdust, wipe it out with a rag and a little mineral spirits, and put fresh on. Storage goes indoors, off concrete, in a drawer or on a wall. Not a sealed plastic tote, because a sealed tote in a garage traps humidity and cycles it. A drawer in the house is better than a climate-controlled box in a shed. And here's the honest math on why it's worth the minute. That drill was built somewhere in the neighborhood of a century ago. It has already outlived the company that made it, the man who bought it, and my grandmother who used it for 60 years. It is not going to wear out in your hands. The gear teeth on a hand drill see a few hundred revolutions a day at most under a human arm's worth of torque. There is no realistic use case where you consume that tool, which means the only thing that can end it is neglect. It is not a question of whether the tool lasts. It's a question of whether you do your part. One thing, not 10. Buy 2 pounds of food-grade citric acid. Grocery store canning aisle, farm store, or a brewing supply. $8 to $12. That's the entire purchase. Then find one rusted steel object you already own and don't much care about. A pair of pliers, a hinge, a wrench from the bottom of the toolbox. Do not start on something you love. 1/4 cup per gallon of hot water in a plastic bucket. 4 hours. Baking soda rinse. Hot rinse. Hairdryer. Oil while it's warm. Total time in your hands, about 25 minutes spread across an afternoon. Total cost, under $12. And what you'll have at the end of it is not a clean pair of pliers. What you'll have is the knowledge that the crust was never the tool. That every rusted thing you have walked past at every yard sale for the last 20 years was a working machine with a chemical film on it, and that the film comes off for the price of a sandwich. Once you know that, you will never look at a $3 box of orange junk at a farm auction the same way again. You'll start seeing what's under it. And I'll warn you now, that gets expensive in a different way, because you'll start buying boxes. Next week I'm going into the same box that drill came out of, because there was a handsaw in the bottom of it, under a coffee can of nails. Most old saws are worth saving, and some are worth nothing. And there's a 10-second test with your thumb and your eye that tells you which one you've got before you spend a single evening on it. I'll show you the test, and I'll show you the one thing on a saw plate that means put it back down and walk away. Verna never called what she did restoration. She never called it anything. There was a rag on a nail, and a can on the sill, and a drill in the drawer. And she used it for 60 years, and handed it to me without a word about it. The rag cost nothing. The oil cost 11 cents. Wipe the tool before you put it down.